Okay, let me start with some reminders for you. Okay, number one, so your Lab 0 Part 1 will be due tomorrow, Friday, 12 noon. So please make sure you submit before the deadline. The submission is set to close automatically at 12 noon. If you miss it, you miss it. So please, in time. Okay? And your priority, hopefully now, would be for Lab 0 Part 2. So you really want to get started. So the materials covered in the Part 2 of Lab 0 will be more demanding for study. Especially we talk about primitive array and how you can combine primitive array and reference attributes. So that's going to be the pattern we're going to use for the rest of the course. So please make sure you give yourself enough time to study Part 2 of Lab 0. And for yesterday, I did 2 demos in the lab sessions about helper methods. So I just want to show you where you can find the materials, and it will be up to you. But those materials are assigned readings on your review slides. You can go over the slides if you think that's enough, or you can also look at the demo. So if you go to the study sites over here, you will see under the comment section there, I put in-lab demo over here for section E and F. Right? So I talk about 2 different examples. But it's really important for you to really learn about the principle of why we are doing helper methods, which will be to get rid of the smell of your code. That's something you really want to spend some time thinking about. And maybe start applying in all your labs, starting from lab number 1. That'll be a very good practice for you to have. All right, let's now get started. So today, what I would like to do is, I would like to start from slide number 48 after the after the demo on the Eclipse. And remember, from slide 16 to 47 has been assigned to you for reading. The slide is pretty self-contained, and I'm going to cover most of the concept that's mentioned in those slides in the little code demo I'm going to do. So we're still going to review the stuff. And it may not hurt just to spend a few seconds just to see what we covered last time. How about that? Very quickly. All right, so last time we actually spent quite a bit of time talking about this observe, model, execute process for object orientation. Especially for this course, we're going to focus on model and execute. So for the model part, you will be given some JUnit test cases from which you're going to infer the classes and methods that you have to implement so that they will execute properly according to the JUnit test cases. All right, we spent quite a bit of time talking about the process. Make sure you review them. And then we talk about refactoring, especially helper methods. And we talk about this summary table over here just for you to understand every time if you want to design your own template. So these are the checklists of the items you have to somehow think to yourself about. If I have a template, what should be the common attributes and what should be the instance-specific values that the attributes might be possessed by their individual entities, right? And we talk about Java data types, especially primitive versus reference type, right? So these are the 2 rules I mentioned last time, and make sure you review them. And we talk about how you can visualize primitive versus reference type last time, and today I'll dive deeper into, especially for the reference type, starting from creating an object in the memory and how you can invoke either accessor or mutator methods on the context object. That's something we'll get into today, so you can expect that. And we'll talk about null pointer exception, right? Just make sure you're aware of this kind of exception. Again, I don't think you can 100% avoid it. It's not quite possible, but at least you gotta be aware of this problem here to see how it can occur. If that really occurred to you, either during your lab development stage or during your programming test, you should really see how you can find out the cause of the problem, right? So this is something we talked about last time. Make sure to review it if you still got doubts. Yeah, self-study, right? That's a sign. And parameters versus argument, which we're going to also apply today when we trace the code. It is so important for you to know the difference between this and this when you trace the code. It's fundamental. But I will review that as well today. And we'll talk about scope of the variables. And that's also something you want to watch out for. But today, we're going to talk about some interesting case, which will require the use of the this keyword. And we'll see that, okay? We'll get there slightly later. Any question from last time's lecture? Any subject you want me to explain again or anything you want me to clarify? Let's now move on. What I'd like to start with will be from Eclipse. Okay? Let's now develop some small project from scratch. And I already started with Eclipse on my workspace, and then let's now create a new project. File, new Java projects. If the font size is a little bit small from the ID, that's okay. If you rewatch a recording, it's actually quite crystal clear. But for now, I'll read it to you whenever there's important information. Make sure under module section here, don't select create a module file. I think some of your classmates emailed me about the problem, so that's what they did. So please make sure you don't select this option here. And also for the Java ID version, if your computer supports anything higher than 21, don't select it. Choose only up to 21. Otherwise, your code would not be compatible with the remote lab. Okay, please. And let's call this project here persons. Okay, finish. So now I got a project here, and let's not worry about creating different packages. I can leave that to you when you get access to the source code. Let's only create two classes for today. Number one, I want to create a model class called person. So it's new and then class person. Finish. Okay. So person is similar to, well, it's a template for entities such as Jim and Jonathan that we spoke about last time, right? Let's say we only want to characterize a person entity by weights and attributes. Let's say only these two for simplicity. Okay. That's now attribute number one. Double, that's the type. Weight. Let's document this slightly to say we assume that it will be measured in kilograms, not pounds. And also double height. It will be measured in meters. A bit strange, but just to make the calculation a little bit easier, rather than centimeters or feet, right? And of course, you can document the code if you wish. You can say these are the attributes common to all person entities. And actually, I was very thrilled to hear from some of your classmates. They said, is it okay for me to add additional comments in addition to what you wrote on the video? Yes, absolutely. I would say it's a very good practice to really add the insights into how you understand the code, especially starting from lab number one. Things will get more complicated. It's really for your benefits for later review. I will encourage you to do so. The worst thing you want to do is to have no comments in your 1,000 lines of code. Let's say 2 months later, 3 months later, if you don't review it for the exam, you might get confused. Okay, that's my tip for you. All right, let's now move on a little bit. Okay, question for you guys. Here's an important question. This may be the simplest class I can create. Am I ready to start creating person objects, even though I don't have any constructor here explicitly defined? Yes or no? Am I ready? Yes? How come? That's default constructor. Okay, that's good. Okay, but for those of you who didn't know, I'm going to show you. So point number one for today. Even if you don't define any constructor explicitly for your own class, there will be a default constructor ready for you. Point number one. Okay, let's illustrate that. So what I'm going to do, let's not worry about JUnit tests. I'll leave that to you as exercise. Let's do a console tester so we can see some output just for illustration. Another class, let's call that person tester. All right? And I'm going to choose a main method so that it's executable. All right? When I say executable, I really meant there will be sequential lines over there for me to manipulate the entities. Right? Finish. I'll make it slightly bigger for you. Let's now try to create a first-person object. Why don't we call it Jim? I'll explain exactly what this line really means, but for now, there's a slightly different thing I want to illustrate right away. Okay? As you guys correctly said, even though at the moment I don't have any constructor explicitly defined in my person class, I can already use the person constructor because that's a default. Okay, let me write down that point. when there is no constructor explicitly defined, a default one is available for use. Okay? And let's dive a little bit deeper. If I say system.out.println, before we predict what's going to happen, what's going to be printed out, why don't we use the breakpoint debugger to help us a little bit? And I'll go back to ask you a question. Debugger, right? You guys should really already have some experience from part 1, maybe. If you haven't, I highly, highly, highly encourage you to do debugger and breakpoint. During the programming test, if you run into issue, sorry, Jackie cannot help you. TAs cannot help you. Who can help you? Debugger. That's the only thing you can rely on. Cannot emphasize enough. So I'll put a breakpoint here, line number 9. So the execution is going to pause right before I start executing line number 9. So what I would do is I'm going to launch the debugger. It's going to ask me to switch to Java perspective. Yes, I can do it. But if you like, you can just remember your decision. It's up to you. Okay, let me just switch explicitly. All right, don't worry about expression just yet. Let me go to variables over here. At the moment, if you examine this panel over here, there is not any variable for Jim just yet. How come? Because at this point, as I said, we are pausing at the beginning of line number 9 before we execute it. So that's why Jim hasn't existed just yet. All right? As soon as I say step over, you can see Jim is now here. If I click on that in Eclipse, it's showing to me something like a person at 4187553C1. It's the address. You don't really need to memorize the address, but just to know this one address assigned to this particular object. And then I'm going to expand this object over here. You can see here, heights and weights are simply 0. Do you guys know why? It has to do with what the default constructor will do by default. Right? Go ahead, please. Yes. Okay. So default constructor, yes, default values. Default constructor basically does nothing. It doesn't try to initialize or attribute to any specific value. So that means default values, right? We talked about default values last time. So for numerical types, will just be 0.0 or 0 for integers. And then under the expression, right? Sorry, let me delete these. They're just from before. By the way, if you don't see variables or expressions panel in your debugger, don't panic. Very easy to bring them up. Go to Window, Show View. You can see variables and expressions here. Right? You can easily bring them back. All right. So if I put, for example, Jim over here, it tells me that's an object, right? So you can type any expression you like in the expressions view. That could be a nice complement to the, nice supplement to the variables. You can play with it. Now that we know the contents for this object Jim is 0.0 and 0.0. Question for you. I'm now pausing at line number 9. As soon as I say step over, it's going to execute system.out.println Jim. What do I expect to see? 0, 0, 0.0, 0.0, 0.0. What do I expect to see?
Sorry.
That's okay, please. The address, very good. If you want to print out the content, you got to do something a little bit more sophisticated, which you will do in lab 1. But for now, the simplest printout of an object is print out its address. So now if I say step over again, exactly right? You can see that's the address over here. Guys, so far so good? All right. Let me now, and whenever you say, I'm done with the debugging, I want to go back to Java, please, please, please make sure you stop the debugger first. Otherwise, you're going to run into trouble. If you don't stop the debugger, go back to Java editor, and then editing your code, your Eclipse is going to crash. All right? Stop it explicitly, and you can go back to Java perspective. That's where we are. All right, so point number one is about default constructor. Now, default constructor is useful and useless at the same time. Useful because you can create objects right away. It's useless because it doesn't do anything to initialize the attributes. So what should we do? Let's create some customized one. User-defined or programmer-defined constructor. So what I will do is I'm going to go back to the person class, and then I'm going to define some constructor over here, which must be public, and the name must be the class name, person. And for now, I'm going to choose some parameter names that are different from the weights and heights. You might be wondering, what if their names are the same? Don't worry, I'm going to get to it. Not yet. Okay? For now, just for illustration. Double new weights. Double new heights. Something like that. So this is a user-defined or programmer-defined, however you want to call that. And apparently I made a typo here. Let me fix it. And let's stop right away. I have some error. Did you see that? There's a red cross over here, right? Every time you're trying to do incremental developments of your Java projects, always pay attention to if you got any red cross over here. If you do, fix your code first. You don't want to program for your project for 2 hours and then got 200 errors. It's too late to fix. Well, as soon as you got the first error, fix it right away before you move on. So it should be incremental. All right? So we got an error here. In this particular class, what used to compile when we use a default constructor does not compile anymore. That's point number two, which I will tell you right away. When you have no constructor in your class, default constructor is there, available. However, as soon as you put in the first programmer-defined constructor, default constructor is gone. All right? That's the second point. So here, if you, let me write it down. As soon as the first programmer-defined constructor is placed, the default constructor is no longer applicable. I should really make less typo, but I'll try. All right, you see my point over here, right? You should really get very clear why we didn't have compilation error before, but now we have it. Now, how do we fix it? Either you get rid of that programmer-defined constructor, just use a default one. But that's not what we want. We want to use something that's more useful. So to do it, we have to make sure when we call this constructor over here, now there's only one constructor available, which is this one we just introduced. So we want to call that one instead to get rid of the error. Okay? So what we want to do is new person, weight and height. Let's say 72 and 1.81. And no error. Everything clear so far? Any confusion right now? Go ahead.
On the previous class,
Mm-hmm. Okay, the question was the new weights and new heights back in this person class over here. You are talking about this and this, right? You were asking, are they attributes or something else? Okay, they are variables. Everything is a variable. But now let's be more specific. They are not attributes. Attributes are the class level variables we declare over here as we talk about the scope, right? Number one, they are not attributes. Number two, for you, are they parameters or arguments? How come? Are we defining something or we're using something? We're defining the method, so that's why they're parameters, right? Remember the principle, right? We covered that last time. Make sure you guys review. So the new weights and new heights, they are parameters. And for now, I deliberately choose their names not to clash with the attribute names. So we can do some simple tracing first, but I will change them a little bit later. And how should we define over here, right? the idea would be our intention is we want to initialize the weight attributes to be the new weights. We want to initialize the weight, height attribute to be the new heights. That's our intention. Oh, you should not be surprised if I put weights is assigned to new weights. And heights is assigned to new heights, right? Guys, are you okay with this? Okay. And important thing to note on the Eclipse. I want to draw your full attention here to watch the color of the fonts. Eclipse is doing something very useful for you. Number one, you can see the weights here and the new weights over here, they are of different colors, right? Even more, if you click on the weights over here, it's referring to the weights at the top. So that means whenever you're talking about this weight over here to be assigned to, you're really assigning to the attributes, which is what you intend to do. On the other hand, if you mouse click on the new weights over here, it's referring to the new weights. That's a parameter definition here, right? So that means we're really trying to assign whatever that's being passed as new weights into the weights attributes. So whenever you have any doubts about where this variable comes from in the middle of my method, click on that, and Eclipse is going to show you where you can trace back to the origin of the variable. That's my point. I believe every IDE will do something like this. And just one example in Eclipse. All right? And we're going to come back to this nice little feature to help us understand shadowing for the variable in just a moment. All right? We're all good for now, and now it's time to do a little bit of tracing. But before that, let me just do one more, a few more lines. 2 more lines, how about that? So I already got person Jim, and why don't we create another person, Jonathan. New person. And let's use 65 and 1.67. All right? Let's say all I want to do is, let's say, Jim equals Jonathan. And then let me do another one, but you will see more on the iPad notes, which you can play with as well. I'll leave that part to you. But let me just have another one. Not equal to, right? Exclamation mark means not, right? Back in first year. Now, can you predict what's going to be the output in these 2 lines before I use the breakpoint debugger to tell us? Anybody? Let me try with you first, please. How about first line? First line. Line number 14. It's going to be false because the memory addresses are different. Very good. They're different objects. Fantastic. How about 15 here? We're basically asking the same thing. We're just saying that, are they different objects? Yes, they are different objects, so that's why it's true. Okay? Good. I believe I did something like this, maybe back in the refurbished shop example, using equal, not equal to, right? So please make sure you understand the logic over here. All right, that's good. And let me use the debugger. I want to show you one more thing. Okay. Can we just, I think the same breakpoint will be fine. And then let me run the debugger. So we're going to pause at line number 12, in my case, right? Line number 12. So at this point, you can see both Jim and Jonathan have not been created. And we're going to create 72, 1.81 for Jim, and 65 and 1.67 for Jonathan. I will trace how this constructor call can be understood maybe a little bit later. For now, let's focus more on what's going to happen quickly. So if I say step over, so we execute line number 12. So we got Jim already. So now you can see if you expand Jim, you got 72 and 1.81. That's correct. Okay? If you step over once more, you're going to have Jonathan here and then expand it. You can see number 1, Jim has this address over here. And Jonathan, click on that, it has a different address, just different. That's why equals is going to give you false. And then if you want to compare the contents of the objects, you will see their heights versus this is different. Like a 1.81 versus 1.67. They are different. All right, just important for you to see some useful information from the debugger. Yes? Say Say that again, sorry?
Like if you don't put any quotations in the print line, like does it default to Boolean? Like
If I don't put any, you mean quotes, right?
yeah.
Okay. All right, so if everybody's okay with the debugger, let me stop the debugger and answer your classmate's question. Stop here and go back to Java. Oh, let's just verify before I answer your question. How about that? Let's just verify the output. If I click on that, and false and true, right? That's what we predicted. That's good, right? The question was, if I didn't have the quotes, you really meant to say something like this, am I right? Okay, sure. Why don't we do that? Yeah, that one there basically just printing the string verbatim. It's not doing any comparison. So line number 14 is simply say, I want to print out this string literally. This is to say, I want to print out the value of this expression. And this expression, because you're using the exclamation mark and equals, it's a logical expression, which always return a Boolean. So that's why it's going to print out either true or false. Right? Let's verify that before I undo it. If I click on that, it's going to give you, right? This one here, just print it out literally. No meaning, really. Okay? Okay, all is good. What I would like to do is let's now try to see how we can understand the tracing for the object creation a little bit. I want to mention a memory, like a low-level memory view one more time. And then I'll show you a more efficient way to do things in your maybe test. All right, let's do that. Everything's good. Okay, let's now switch back over here. And you will see that on the iPad page, you got some JUnit test case over here. I'll leave the exercise to you. You can feel free to try this code in Eclipse and really convince yourself why all these assertions will actually pass. Well, that'll be left to your exercise. What I will do instead, I'm going to focus on these two, which we just did in the console tester. We talk about default constructor. I'm going to mention again parameter versus arguments and also reference variable. That's something I'll do. Okay. Let's now try to trace the code. Right? Let's see this. So when I try to execute this line over here, all right, basically we are saying that Jim as the reference variable, we set aside a box. And that one there is going to store the address of some objects. And then, because we are having some new person expression over here, so we are going to allocate some memory somewhere. You can see I got a memory here. Right? And then I'm going to allocate somewhere, let's say over here. So this block of memory is going to store the information for this object somehow. So let's say I'm going to make this up. So let's say 06123. That's a starting address for this memory. And then somehow I'm going to store 72 and 1.81 in this part of the memory. So I'm going to have 72, 1.81. Exactly how this is done, I'm going to trace that for you a little bit later, okay? And then if we go to, and then we're going to store this address over here into Jim. 06123. You can see that it's very important. We don't store the contents of the objects into the Jim variable. We don't. We only store its address. Agree? Okay. One more. And then when we execute this line here, we're going to allocate some memory for this separate objects. Every time you see a separate new keyword, that means a separate part of memory is going to be allocated. Okay. So here we're going to have, let's say, 06789. And over here we're going to have 65, 1.67. 65, 1.67. And we're going to store the address in Jonathan. So we have some variable here, like a box. That'll be Jonathan. And then it's going to store the address here, 06789. And now, let's go back to the lines that we already verified by Eclipse. If I say this one here, system.out the print line, Jim, it's going to print out this address, something like that. If I do system.out the print line, Jonathan, let me use a different color. System.out.print line, maybe not blue, it can confuse you. This one here, Jonathan, is going to print out this address over here. Agree? And let's choose some expression here in the JUnit test just to help you. What about this one here? Jim not equal to Jonathan. There are two ways to see this. Approach number one. Jim, this address. Jonathan, this address. They are not equal. True. Because this address here is not equal to this address here. So this expression here is true. Another way to see it is when you say Jim and Jonathan is not equal, you're basically saying, are they referring to different parts of the memory? They are, because Jim is referring to this part here, Jonathan is referring to this part here. They're distinct parts of the memory, so they are not equal to each other. So that's why this expression here is true. Two ways to see it. Any question for this? Yes?
What's the difference between not saying and not equal?
Not saying and not equal. Okay, good. The question was, I think you got a very sharp eye. What's the difference between not saying here and not equals here? That's your question, right? Good. This will be covered in much more detail when we talk about JUnit testing for equality, right? But let me mention briefly. This one here, not saying, is really saying I'm comparing using equal. In the case of reference variable, we're comparing addresses, okay? And not equals over here is slightly trickier, but you can think in this way. This is really saying Jim dot equals Jonathan. So whenever you, but since you got not over here, right? So you got to put an exclamation mark over here, all right? So this assertion here is basically asserting whether or not Jim dot equals Jonathan is true. Basically what it is doing. However, the complexity is the equals method may have a different definition depending on Jim. That's something we'll talk about later.
So like string, for example, has a not equal.
Yes, string does have a, so let's not get too much into it. But just remember the equals method for string will just compare contents. But whenever you got some different type of context objects, it depends on how you define the equals method in that particular class. That's what you should know for now. And we'll leave the complete story for 2 weeks later, if that's okay. All right? Question, please. Absolutely. So the question was, does the computer allocate enough memory for all the attributes in the object? Yes. I think for these days, memory space is not your concern, for sure. And usually for Java application, the objects required it wouldn't take that much space. So I don't think that space should be a concern over here. And once you guys get to 2101 next semester for data structure, you will realize what's really important is about the speed of your algorithm. That's something we'll get into, called running time. Yeah, we wouldn't touch upon that for this course. For this course, it doesn't matter if your code runs fast or slow. As long as it terminates, that'll be fine. If your code doesn't terminate or run forever, too bad. Okay, just remember that. Any other questions about what we said so far? Alrighty, so everything's good. And this will be the last time I'm going to draw diagrams like this for memory. It's a very nice way to understand the hardware a bit. But I think for our purpose of this course, which will be more software-oriented, when we try to solve tracing problem, drawing a memory diagram is going to slow you down too badly. Let's not do it. I'm going to show you a more efficient way pretty soon. Before that, let's now modify our example slightly. And now let's get to the more practical way of doing constructor. What I did over here is I deliberately chose names of the parameter that are different from the attributes, which will cause no confusion. However, in practice, many programmers will rather say, since I really want to use this parameter over here to initialize weights, I want to keep it the same name. I don't want to come up with a new name. I don't want to. Similarly, this parameter here is meant to be used for initializing this attribute over here. So I don't want to choose a different name. I want to choose the same name. That's a fair concern. Let's try that. So what I have done instead is here. The same class. I also define something that will act like what the default constructor would do. But if you don't like it, you can get rid of it. That's OK. Don't let it distract you. We got the same two attributes over here. And also, we got our customized version of the constructor, right? But now, instead of calling the parameters new weights and new heights, I call them weights, heights, weights, height. I want to say, I really want to use this weight to initialize the weight over here. I really want to use the heights to initialize the heights over here. That's my intention. And that's why I got this. I cannot use new weight and new height over here anymore because they don't exist. I already renamed them, right? Stare at this new version for a moment. Is it going to, two questions here. Number one, is it going to compile? Number one. Number two, is it going to do what I intend to do, which is to initialize those two attributes? Two questions here separately. How about question number one? Is it going to compile?
Yes.
I agree, because in some way, we are basically doing some variable assignments over here. As long as the two sides are basically the same type and they're both declared variables, you're fine. So they will compile. So if you do this in Eclipse, you're not going to run into any, like a red cross. So that's OK. So submitting this for programming test, at least you wouldn't get any penalty for compilation error, at least. Question number two, is it correct though? Not quite, okay? Let's see from Eclipse. As I said, Eclipse can give you very good hints about why this is not correct. Let me show you. Go back to Eclipse over here. Go back to the person class. And let me rename them, as we said. Weights and heights. And here, weights and height. OK, answer to question number one. There is no red cross for the Eclipse project, so we are fine. Compilation-wise, it's fine. Question number two. Are we really doing what we intend to do? Let's see Eclipse, how they give us some hints. If you click on weights over here, what we intend to do is to assign to the weights attributes, right? But now, if you put your mouse over, it's actually referring to the parameter. It's not referring to the weights. That's the issue. Similarly, if you actually try to move the mouse over here on the heights, what we intend to do is to assign to the heights over here. But the height here is referring to the heights over here. Right? So we are basically assigning weights parameter to itself. Right? You can see the weights here and the weights over here. They're referring to the same weights. We're assigning a variable to itself. Nothing useful here. Can everybody understand what I'm trying to say here? Right? That's an issue. And this is something called variable shadowing, which is also mentioned in your slides, but let me visualize that a little bit. Now, you want to think about it this way. The weight parameter here, let me write down the term first. It's called variable shadowing. What is shadowing? It creates a shadow somehow. The way I think of it is like this. The weight itself is going to create like an umbrella covering everything underneath the method for this constructor here. Now, if I want to refer to this particular weights over here, what I intend to do is I wanted to refer to the weights attributes, but I cannot because it's somehow blocked by this umbrella. It's being shadowed. All right? So this weight over here is no longer be able to refer to the weight attribute. Instead, because of variable shadowing is really referring to the weights over here. That's how you should understand variable shadowing. So the weight is referring to the weights over here, and the heights is referring to the heights over here. Let me use a different color. Okay? Question? Yes.
Is there a reason why they use the same name? Like, can't you just say like weight attribute, and then just say that?
I think that the question was, can we simply name them differently so that there's no confusion about shadowing? It's a valid concern, but we are talking more at the software design level. Usually people say, the simpler, the better. In your case, if you want to come up with different names for the parameters and attributes, in some way you're making the naming mechanism more complicated. People can argue that way. So what they want to do is, if, let's say, this parameter, let me say that again. If you look at this parameter here, let's say this one here. If my intention is to use this value over here that's being passed to initialize the corresponding attributes, it would be very nice if I can make it explicit by having the same name, so I can see some correspondence. But because of variable shadowing, I cannot do it just yet. I need some extra mechanism to allow me to do it. I need something to help me disambiguate to say, when I refer to weights over here, I'm really talking about this weight. When I'm talking about this weight over here, I'm really talking about this weight. At the moment, there's no way to disambiguate. Okay, can I answer your question here? Okay.
On a test, like, would you want us to use this?
I would say this kind of a choice is more like a personal choice. I would say you can go either way, unless I explicitly say you cannot do it. Okay. However, I will encourage you, once you understand how to solve this problem, right, the better practice, then I would suggest maybe use the same name as an attribute. That's what everybody else does. Okay, good. Now, a very good solution goes like this. Number one, we want to have the same name as the attributes. Number two, we want to somehow break through this umbrella to this attribute. What's the solution? We need the this keyword. All right? The way to do this is is like this. We want to use the keyword this. Dot. This. Dot. What this does for us is like this. Whenever you see this dot, that means we're referring to something at a class level. As we said before, parameter is at the method level, so that one doesn't apply. So this effectively allows you to break through the shadow or break through the umbrella informally, and you can refer to the weights over here. That's what's happening. All right. So if you do this weights, it really allows you to really get to the weights over here. And similarly for this the height. So this, what I have illustrated so far is when you have the same name, let me summarize and then I can move on. When you have the same name of the parameter, the same as the attributes, in that way, if you want to refer to just a parameter, yes, you can say weights. However, because of variable shadowing, if you want to refer to the attributes of the same name, you need to disambiguate by saying this dot. So Java compiler would know which one you're talking about. So this is method level. This is class level. When you want to do the class level access, you have to say this dot. That's the rule. All right? And in every OO language, this will be the same case. I think maybe in some OOP language, maybe they wouldn't use this. They use self, S-E-L-F. But you know, the same idea. Question?
So if they're different names, you don't have to use this, right?
That's correct. If they are different names, you know what? Yes and no. So I would say, that's a good question. Let me make it explicit. The question was, what if if I have there is different names, can I use this? Yes, you can use this, and it's not going to cause any error. And no, you shouldn't use this because it's not necessary. That's why I say yes and no, right? Let me just show that to you. Oops. Okay, let's say we still have, let me make it bigger. All right, let's say we still have the new weights, sorry. Let's say we still have the new weights and new height, no name clashes, right? So here, the weights, if just by itself, there's no ambiguity, that's okay. But if you want to say this the weights, that's also fine. Because here, you're still referring to the class level weights. So the consequence is the same. So I would say you can go either way. Okay. Good question. I like that. All right. So this is also fine. All right, guys. Any question about using this to disambiguate variable shadowing? I would say usually when you learn about the keyword this will be the first example you will see. I would say that's a simple one, just to disambiguate. And on Tuesday next week, we're going to see a slightly more advanced usage for the this. That's something we'll see next week, okay? But one step at a time. All right, so after this, we're going to talk about defining accessor and mutator. That's what we'll do, okay? And before that, okay, accessor mutator. Okay, let me do that just a moment. I want to do one more thing. I want to show you how you can trace the code and understand object creation. Just one more page, bear with me. And what we said before about tracing using the memory, as I said, that will be very good for your knowledge to make a connection to the hardware. But let's see how you can trace more effectively. Okay? Let me first of all show you some convention, and then we'll see some example. So whenever you want to trace OO code, you have to see how the objects are created, and this will be how I recommend you draw. And this will be how I draw throughout the course about tracing OO code. Right? I will encourage you to follow really my convention as much as possible. That one can really be clear and also effective when you do the trace the code. Yeah, these are the rules. You can read them, but I'll show you. This will be one typical diagram you will see. Well, part of the diagram you will see. Let's start with this. Jim over here is a reference variable. And the person over here is the type of the variable. It's a reference type, apparently. So the fact that we actually got Jim and person over here. Yeah. The fact that we got person and Jim over here, these two combined, that tells us somewhere in our code, we actually got the following declaration. Person, Jim, somewhere. All right? So the box over here really is like a portion of the memory. And we are telling the reader that the type of the object or the entity is a person. And this particular variable who's going to store the address of this object will be Jim. Okay? The box itself has also the left and right columns. The left columns over here are the attributes defined in the template. And then here, the right column here, which are the more specific values. So these are the instance specific values or object specific. So here we are saying that Jim is a reference variable which stores the address of this particular person objects. And that particular person object has age 50, for example, and etc. All right? That's a very, that would be the simplest way you can really kind of abstractly draw an object for your tracing purpose. We're going to see a lot things like that. Okay? One more thing, which is also important. And the arrow over here, right? The arrow over here tells you Jim does not store the contents of the object. It does not store 50. It does not store 80 British 1.8. It does not store that, right? It only stores the address of this object here, which we don't really annotate here. It's low-level detail. So the green part, the green one over here tells you Jim stores the address of. That's how you understand every bit of the diagram over here, right? Any question about understanding this diagram here? Of course, at the runtime, let me give you a little bit preview. You might have multiple boxes, multiple objects there. You might have arrow, arrow, arrow. That's easy. But you might have, for example, two arrows pointing to the same objects. Or you might say now, rather than having this point to here, I wanted to point to this object instead. This is where things will get a little bit tricky. So that's why you really need a systematic mechanism to help you trace or keep track of. But we're going to get there. Okay? All right. Let's now move on to this code over here. Right? We're using the this keyword. Right? And I would like to just trace with you very quickly about object creation. I just want to do one. All right? Just do one line. I want to really break it down into the phases so you can understand exactly what's going on. That's important. And then we'll do accessor and mutator. Okay? So let's focus on just this line. How about this? Can we only look at this line? Just this line here. So I'm going to write it down. So we got person, Jim, assigned to new keyword person. 72 1.81. That's the line. The way to understand this line, I'll break it down into three parts. Part number one. And part number two. By the way, for part number two, you can see this is like only the new person something, right? This is actually a valid object expression called anonymous objects. That's something I will review next Tuesday. Okay, but just for you to be aware. And part number three is here. All right, let's talk about these three parts one by one so we understand object creation fully. Part number one. We just declare a variable. Declare a reference variable, Jim. You can think about we just put Jim aside over here. We don't need to draw the box anymore. That's too low level. Not for now. All right? Just Jim. Have Jim ready. He might point to something later. And what about part number two? Part number two is going to allocate some space in the memory, and then they are going to actually invoke the constructor. Okay? So you can think about what's going to happen is this. We're going to have a box over here, and then we got type person, right? So since we talk about person. And we know according to the definition of the person template, we got weights and heights. That's why we can put weights and heights over here, right? Everything has a reason, right? Not arbitrary. Now, how do we trace to see to fill out the value 72 and 1.81? Let me go into detail a little bit. So here we are calling the constructor that is defined over here, right? That's the only constructor we are talking about. So let me highlight that. Person constructor here and the person constructor over here. Imagine that if we put a breakpoint over here. If I put a breakpoint over here, I say step into. Okay? It's going to step into this constructor here. Agree? So it's going to go to this constructor over here. And now, what's going to be the weights and heights? Now you need to apply your knowledge for arguments versus parameters. So what arguments do we have? 72, 1.81. The corresponding parameter for 72 is weights. So that should be replaced by 72. Every occurrence of that parameter should be replaced by the argument 72. Similarly, 1.81, the argument should really replace the corresponding parameter height. Also, every occurrence. Are we good? That really relies on your understanding of parameter versus argument. We got to match, right? And what about this? In the case of the object creation, it could be slightly implicit because we don't really have a context object yet. You might say, well, context object is Jim, isn't it? Not quite, because we haven't really connect Jim to this object just yet. So at this moment, when we say this, we are really referring to the object that's being created right now. So this is this. All right? So you can think about that this over here is the object being created, which is over here. Yeah, let me down put arrow, just like that. All right? So we are saying that the weights of this object here should be assigned to 72. And the heights of this object over here should be assigned to 1.81. Right? That's what we're saying. So I'll put it down. 72 and 1.81. That's step number 2, right? Which does involve a little bit tracing of the constructor. What's missing is step number 3, which is to say, I want to store the address of this newly created object here into the reference variable Jim. But we don't really want to get back to this particular low-level tracing anymore, which is here. That's not something we want to get into. We want to think a little bit higher level for tracing. Okay? What should we do? Arrow. So we're going to say is, by executing this assignment operator over here, so now Jim is going to point to this particular object. That's number 3. That's the 3 steps for object creation. Once you understand these 3 steps, it would be, well, it would be nice for sure, but of course, later on, if part of your OO code is object creation, you don't really have to think about these 3 phases that in detail anymore. You can just draw the object directly. But I'm just saying that you should understand this to begin with. Okay. Guys, any question about this? Yes, please. Yes, you can think about that way, but think about this is referring to the context object conceptually. And the context object could be the object that's being created or the object being invoked, the method upon, either way. Mm-hmm. But the referencing a bit, again, is a little bit more low level that we don't want to think too much. Yeah, good. Yeah.
So for the part that is
Yeah.
sending the arguments to the constructor,
Yes.
can we do, like, instead of like double weight and double height, have this dot weight and this dot height? Would that work by any chance?
Okay, interesting. Okay, let me just make sure I'm understanding correctly. Did you want to change over here or you want to change over here? Which one do you want to change? Over here, right? Over here. Oh, you want to say, okay, so instead of saying weights over here, you want to say this dot weights.
Yes, I think we need to also get rid of the double as well.
You cannot do that, first of all, because here we're defining the parameter, which is a variable. So you have to give a name. So this over here cannot be part of the name. Cannot be. So, okay, so this is the definition of a parameter. But here is some access to the attributes. So there are different things.
Yeah, I was wondering if you can a bit, because like basically it's like sending the like those values to the local
Yes.
variables and the method. So, if you just like also get rid of the double, because the double is like sort of defined with the variable. Just like have instead of double, you just have this that way. So would that also work? Like,
What you're saying is, if I replace the double over here as a type, what if I just put, for example, this dot weights? And the compiler should really note that this .wait is double, so you can infer that this is really about double. That's your point, right? I love that point. That's a very intelligent suggestion for Java, but you cannot do it now. I'm sorry, you cannot do it, okay? Yeah. What you're talking about, if you're interested, I understand exactly what you mean. You're talking about something called anchor type, anchor. Some programming language supports that, but not Java. If you take a compiler course, for example, 4302, you can define a language like that for yourself. That would be awesome. But sorry, not Java. Good, I like that question. Yeah, guys, please don't try. If you do this wait here, it's not going to compile. Don't try, okay? I'm just telling you, it's a good idea, but Java is not good enough to catch up with you, sorry. Okay, so let's now move on a little bit. Let me do one more tracing over here quickly. So this will be, we have some accessor and mutator. Let's now try to trace them together and use that new mechanism we learned, how to draw diagrams, right? This will be quick. After that, I just got 2 more pages to go over. Hopefully, we can take a short break and got the last 10 minutes for more stuff. We'll see how we go. So we have our person class over here. We got the 2 attributes. And now we got one accessor because it returns a double. We got another mutator because it returns void. Right? It's going to modify something. And the accessor here, get BMI, is going to, well, for those of you who don't know, the BMI is a body mass index. It's the weight divided by the square of heights. All right? So that's just a formula. So this is why you say the weights divided by the square of heights. We don't really have to use the math and power method. We don't need to. You just multiply the same variable twice. That'll be enough. Okay? That's the accessor and just return a value. And then mutator here, because it returns void, so we are just modifying, you see this weights, right? We're modifying the weights by this much. Right? Good. Now, that's something we would like to trace. And guys, how about this? Why don't you look at this fragment of code here? I'll tell you where to focus. 1, 2, 3, and 4. Take 1 minute to stare at this piece of code. I got 2 questions for you. Number 1, are these 2 lines going to give you the same result? Number 1. Number 2, are these 2 lines going to give you the same result? 2 questions. 1 minute. Okay, 30 seconds. Let me repeat the question. Are these 2 lines going to give you the same result, yes or no? Are these 2 lines going to give you the same result, yes or no? Right? All right. First question. Are these 2 lines going to give you the same result? No, because different persons, or more generally, different context objects. Okay, good. Which we covered last time. Good. Jin and Jonathan, different context objects. Hey, but here, the same context objects, Jim and Jin. Yes or no? Why? You're contradicting yourself. You said before, different context objects, so they're different. But now, I got the same context objects. Why are they the same? Please. Yes, exactly, right? As you can see, I'm trying to mislead you, right? You got to be confident about your answer, all right? Maybe you were not confused, I guess. Maybe I'm only confusing myself. Here, you can see here, even though we got the same context object, Jim, over here, and the same method over here, But the context object Jim over here, if you compare here and here, there was an intermediate mutated method call, which modified the attribute value, which is going to impact the calculation of get BMI for the second time. That's why they're going to return different values. This happened very, very often in OOP. All right? And let's now trace them very quickly. Before that, question.
In the first two tests for the search tools, it compares the BMI of Jim with the value of the first value.
That's correct.
Bracket, right? And then it'll show a Boolean.
Yes. Well, not really Boolean. You know, assert equals basically either it's an assertion. It's not Boolean. It's either pass or fail. It will pass if the expected value and the actual value is within the tolerance of 0.01.
Okay, so when you're asking if it's the same as the
That's correct. That's correct. I'm asking whether Jim.getBMI is equal to this.
okay, but the question you just asked, you're asking if it's the same as the Jonathan one. Is that what you're asking?
The two questions, yes, whether these two are the same. That's question number one. They are different because different context objects, right? And question number two, are these two, even though they got the same context object, are they the same? Also, no, because as your classmate correctly pointed out, they got some mutated method call, which will modify the variable. Okay, very good. It's good to ask, so we can reaffirm. Why don't we trace this very quickly? Okay. What I would like to do now is to trace this code line by line. And this will give you a feel about how you should really trace the OO code effectively. Let me do this within a few minutes, and we'll take a short break. How about that? Okay. Okay, line number one. So we are tracing this one here. So this one, we got basically Jim, right? And we got a new person over here. Let's say this is the new person object we're going to create with the weight and height. But now we are calling this constructor over here the first time. The constructor, okay, so maybe for this part, you already know how to trace. I can refer you to the definition earlier, all right? So let's omit this part, just save time, all right? So for this one here, it's going to initialize Jim.weight to be 72 at 1.81. And Jim is going to point to this object, right? That's the first line. We know that. Okay, that's how you trace. And the second line here, Jonathan is going to be another reference variable. And we got 65, 1.67. 65, 1.67. And because of the assignment, Jonathan points to that. That's object creation. And let's now get to this line here. Jim.getBMI, right? How do we trace this? GetBMI is the method over here. We call this for the first time. What's this? What's context object? Jim. That means when we try to step into this, every occurrence of this is going to be replaced by Jim. So we're going to return the value of Jim.weight divided by Jim.height squared, according to these values. So that's what you will get. On the other hand, if you try to do, let's say, this second line over here, Jonathan.getBMI, we're basically executing the same block of code for the second time. But what's the difference now? It's a different context object, right? And what's this? Jonathan. So replace this by Jonathan, replace this by Jonathan, and replace this by Jonathan. So what we're calculating right now is Jonathan.weight divided by Jonathan.height squared based on these numbers. That's going to give to you this. Are we good? Okay, one more, please. What if we try to trace this line here? Jim.gain weights. That one there is going to call the gain weights by method, which is over here. All right, for the first time. What's this? Jim. Always ask yourself, what's this? Jim, context objects. Replace every occurrence of this by Jim. And of course, the argument here is 3, which is going to replace the parameter amount. So what we're executing here is gym.weights is assigned to gym.weights plus 3. So gym.weight is here, updated by 3, 75. 75, right? Okay. And then after this, of course, if you want to recalculate gym.getBMI, it's not going to go for these numbers instead of the old ones. So that's why if you compare this one here and this one here, they'll give you different results. Okay? Question?
Sorry, so the first number is that the actual BMI? Like
Okay, yeah, exactly. So let me, okay. Maybe you're referring to this number here?
yeah.
That's correct. So we are calling this accessor method here, gym.getBMI. We're expecting this number to be returned.
So how did you know that? How did you know to put 21.977?
How do I know? Okay, because okay, two things. Number one, in order for me to implement this method, I just applied the formula faithfully. Okay? And now to know for given gym over here with 72 and 1.81, how do I know the expected value? I might just calculate it somewhere. Maybe I can use another calculator. I can use maybe paper calculation. So I can do checks 2 times, right? I'm expecting my method call here based on these values for the attributes to return this. That's what I'm checking. This is something called tolerance. So it's like an epsilon. So this is to say, if in order for me to compare fractional numbers, there's no precision. So I have to allow some tolerance. Yeah.
So will it fail if there's no tolerance?
Sorry?
Will it fail if there's no tolerance?
It might fail sometimes, yes. The question was, would it fail if there's no tolerance? All right, guys, please, okay? Other people may want to pay attention, please. All right, so I'll answer your question. So let's say this. If I say assert equals, let's say I'm expecting to get 23.46. And I have some method call, let's say no tolerance, 0.0. Am I going to fail? Sometimes, maybe, sometimes not. The reason why you got some unpredictability is because we wouldn't get into too much numerical analysis background. Okay? The idea would be, when you think about this number over here, it's like a decimal system. Right? Decimal, right? Yeah. However, when you talk about computing something from the method, it's basically using computer. Computer is binary system. Binary and decimal, according to some numerical analysis theory, they may not be exactly equal to each other always. They may not be a perfect conversion. So that's why if you want to compare binary calculation result with the decimal expectation, you want to allow some tolerance. That's why you want to specify non-zero tolerance, some. That's why. Okay. So don't do this. May do this. Okay? Or sometimes people refer that to be epsilon. You may have seen that maybe in your physics class or maybe some other hardware class, maybe. Okay, I would suggest this. I got 2 more very easy slides to illustrate some simple concept. I'll save that for Tuesday, but why don't we do this? Can we do one more trial of attendance taking, just one more time? Okay, have your mobile device ready. If you don't mind, can I skip the break to today? I will just use those last 5 minutes to do something. Okay? Have your mobile device ready, please, and then let's do it one more time. Trial. Not for real. Trial. And this time, I'm going to show to you, maybe it's good to have a timer, so I'm going to give you 2 minutes to check in. Give me 1 moment. If my browser can load. One moment. Somehow Google is not really responding. Okay. Yep, I'm here. Okay, I'll start the attendance taking right now. Can you check in? Oh yeah, ready? Good. And now what I will do is I'm going to start some timer for 2 minutes. All right? Oops, 2 minutes. All right, if you run into any error, I would suggest maybe disable your location, enable it again to refresh it, or maybe keep trying. Now we're taking attendance right now. Please make sure you do it. Anybody got error? Raise your hand. Not many, okay? Just keep trying, please, okay? At some point, it will allow you to do so. So 2 minutes should be a good buffer. Yeah. Oh, the morning class, so you don't need to worry. Yeah. Keep trying. We still got some time, right? Keep trying, please. Anyone still got errors? Anybody? Still, right? Some. Okay. You may want to do it is make sure your Wi-Fi is connected and also enable location again, right? It might help. Less errors, I guess. Still errors? Errors for you?
Not there. I'm just curious. So when you did it in the morning class at 11, it counts our attendance. So perfect attendance is 50% attendance, not.
Yeah, I know. That could be a slight confusion, but as I said, the policy will be if you attend either one, that's okay.
Okay.
So when I calculate, I don't really go with just the 50%, right? I go with if you go to either one. Anyone still got error? Still got error? Okay, I think, okay.
I'm going to go 50, bro. I want that.
Okay, guys, please. So who still got error for attendance right now? I think slightly fewer. So I would say later on, if at this point you got errors, just come to the front. I have some sign-up sheet for you. But I think that it will help every time you arrive in the classroom, make sure the Wi-Fi is connected or use your data and refresh your location. Okay? All right, I think we don't have that much time left. Okay, let's call it a day. I'll see you next time. Okay?